In this video, we're going to look at the adding and subtracting operations for a rational expression. For some of the steps, first make sure you are still factoring everything you can before you perform any operations. Next, keep in mind you do need a common denominator for adding and subtracting. So if you don't have one, you're going to have to find that least common multiple for all of your denominators, and you may have to do a lot of multiplying by all your fractions until they have a common denominator. For the operation, remember you're only adding or subtracting the numerators of the fractions. And also just for the notation, we usually leave our answers with the denominator in factored form. But for the numerator, you do want to do any multiplying or combining like terms that you can. And then sometimes at the end, you may find a common factor after you've done the combining like terms in the numerator. There may be something that cancels from the top and bottom after that step, but don't try to cancel beforehand. Before I demonstrate these steps with a rational expression, I actually want to work it out with regular numbers in the fractions instead, because I'm hoping that will help you to visualize what I'm multiplying by, where do those numbers go, what are we adding, etc. So for this first example, we're going to start off by looking at the denominators, because I can't do any factoring on this since they're just numbers that I've been given. Well, to find my least common denominator, I want to find the smallest number that 2, 28, and 14 all go into. And in this case, all of the numbers can go into 28. So for this first fraction, we have to recognize that 2 times 14 would give me 28. But then I have to multiply that number on top and bottom so that I'm technically multiplying by a 1 here. Now the middle fraction already has denominator 28, so I can leave that one as it is. But then this third fraction has a denominator of 14. So you have to look at this and recognize that we need to multiply 14 by 2. But again, we're going to have to multiply by that number on top and bottom so that we're still technically multiplying by a 1 and not changing the value of this fraction. So now that we've identified what will give us a common denominator, we're just going to perform these operations we've listed. So for the very first fraction, 14 times 1 over 14 times 2. The middle fraction, we didn't have to do anything to that one, so I'm just going to rewrite it as is. And then the third fraction, we need to multiply this 2 out. So I'm going to have 3 times 2 over 14 times 2. Now remember, we're only adding and subtracting the numbers in the numerator, or the top of the fractions, so don't do anything with the bottom number. We're just expecting to get an answer over 28. So if you want to just go ahead and write that denominator, since it's not changing anyways, that's fine. So for the top, be careful about the operations listed. I have 14 plus 5, which is going to be 19, but then we're subtracting 6, so we should end up with 13. This fraction cannot be reduced anymore. There's no other factoring or multiplying or anything else to do. I was really just trying to help you to see the process of how do we get that common denominator. So find the smallest factor or the smallest number that all of your denominators go into, and then figure out what you have to multiply by to make them all match that number. So here's our first adding and subtracting example with rational expressions. And again, I'm kind of easing us into this because adding and subtracting is harder. We already have a common denominator, so I'm not going to have to worry about that step on this example. I also don't see any factoring that can be done. I have just 3, x minus 2, the x plus 1, and the x minus 2. None of those factors can be broken down anymore. So we're really going to get to skip the first couple steps, the first couple things to worry about, and we're going to go straight into only adding the numerators in this case. So since my denominator is not changing, I'm just going to go ahead and write that this will be a fraction over x minus 2. Now on top, we have 3 plus x plus 1. So the only like terms I have are the 3 and the 1. So I can combine those two numbers. And then I usually like to go from the biggest exponent for x down to the smallest. So the order I prefer in this case is x plus 4 instead of 4 plus x, but technically it's fine either way. And then there's no factoring that can be done. There's nothing else that cancels. So we're actually finished at that point. Like I said, this was an easy example. We're just trying to build up the skills of getting a common denominator and then only adding the numbers on top. Okay, so here our examples are starting to get a little bit tougher because I don't have a common denominator right off the bat. Well, the first thing we will want to do before we try and make the denominators match is actually factor anything possible. Now the 2 is fine as is. The x minus 3 is fine as is, can't be factored. X plus 4 is also good. But then here on the right fractions denominator, this is a difference of squares. So I can break this down as x plus 3 times x minus 3. Now that I've factored everything I can, I want to start looking at these denominators to try and make them match. Now the fraction on the right has both an x plus 3 factor and an x minus 3 factor. The fraction on the left only has the x minus 3. So these two things match, but I'm missing the x plus 3 piece. So that's the number I'm going to multiply on the left-hand side, x plus 3. But remember, we can't just do that on the bottom, so we will also have to multiply that on top here. So let's go ahead and perform that operation. I need to distribute 2 times x and 2 times 3. But I'm already at the point where this is all going to be one common denominator now because I can see this is x plus 3, x minus 3, and this is x plus 3, x minus 3. So I'm just going to go ahead and show that the numerators are being added at this point. So I can make the second fraction just fill in right next to this. So it was going to be a plus x plus 4. So I got my common denominator. I did any of the multiplying that I could. Now let's see if there are any like terms I can combine in the numerator. So I have 2x plus x, and I have 6 plus 4. I'm still not changing anything on the bottom of the fraction. I want to leave that as is. And one reason we do this is because it makes it a lot easier to identify the domain or the zeros of the function, whatever weird things you have to worry about from the bottom of the fraction. It's easier to see those when it's in factored form. That's why we often leave it this way. Now I don't see anything else I can do on the top of the fraction. And since it can't be factored anymore and I don't have any common factors that cancel, we're actually done at this point. So I did all the multiplying, I did all the adding. 3x plus 10 does not factor in any way, and it does not match a factor on the bottom. So this is my final answer from adding these two rational expressions.
And now for our final example, we'll do a subtracting case, which means we will have some additional sign changes to worry about later on. But our first step is the same. We need to do any of the factoring that we can. Now for the fraction on the left-hand side, 5 cannot be factored, but the denominator of this fraction can. This is a trinomial, so we want the two numbers that multiply to -6 but add up to +1. So I should get x plus 3 and x minus 2. Now the fraction on the right-hand side cannot be factored. I'm actually going to do something here that I find helpful just to help with the sign changes. I'm going to change this into a plus in the middle of the fraction, and then I'm going to instead distribute that negative through everything on top. So I'm actually going to make this a -2 in the numerator. If I had more terms on top, you would have to apply the negative to all of them in this numerator. That way, we'll make sure we don't forget to apply the negative later on in this question. I'm not going to factor anything in the denominator of the right fraction either though. X minus 2 is as broken down as it gets. So now I can compare my two fractions and see what my common denominator might be. So for this question, I have a denominator of x plus 3 times x minus 2, and the fraction on the right has a denominator of x minus 2. So this fraction is missing the x plus 3 part from the bottom. That's what we're going to multiply. But remember, we do need to do that on the top and the bottom, so that technically we're multiplying by 1 and not changing the value of this fraction. So at this point, we will have a common denominator. Both of the denominators will be x plus 3 times x minus 2. But remember, we're not going to actually FOIL this part out. We only want to do the multiplying in the numerator of the fraction. So from the fraction on the left, we just had a 5 there. There was nothing to multiply by on this fraction. But over here, we said multiply by x plus 3. So I brought that negative up, so I would make sure to distribute the negative correctly. I need to do negative 2 times x and negative 2 times 3. So after the distributing, we'll look for any other like terms. You should have done all the multiplying at this point, but if there's anything else that you still see that needs to be multiplied, go ahead and do that as well. So now I'm just going to do any of the adding and subtracting. So the 5 and the minus 6 will end up equaling negative 1, but I like to write the x term first. So I'm going to do negative 2x minus 1 all over x plus 3 times x minus 2. I'm still not changing anything in the bottom. The only thing that you might end up changing would be if you have a common factor on top, in which case you might be able to cancel something from the denominator. But in this case, I don't see anything else to do on the top of the fraction. There's no factoring that can be done, and it did not match one of my factors in the bottom. So this one is done, although an argument could be made maybe on MATLAB or on some other assignment. They might factor the negative out on the top and then write that as negative parentheses 2x plus 1. So you could do that on top and then leave the denominator the same, but I'm okay with you just leaving your answer in this form in this case. So that's all for the notes on adding and subtracting rational expressions, but there will be some tougher problems where you might have to deal with multiple, more than just two fractions, and then it makes it a little bit harder to get your common denominator. So we'll try and look at that together in class.